Welcome back to another lesson in GCSE Maths from Hartlepool College of Further Education. This is week 13 and today we are looking at multiplying decimal numbers in the area of a circle. Okay, so we'll start the lesson with some revision grids. So on the next slide, what you'll see is a lot of number questions. When it appears, pause the video, the questions, and then when you press play, I'll talk through the answers. The slide after that will all be about algebra. So same process, when it appears, press pause, attempt the questions, and then press play to hear the answers. Okay, pause the video now. Right, so looking at the first one, it's all about bid mass. So remember, brackets, then index, then division, multiplication, addition, subtraction in that order. We start with the brackets, and within the brackets there is a multiplication. So 3 times 7 is 21. Multiply that by the 4 on the outside of the brackets. 4 times 21 is 84. Add the 1, total of 85. Next up, brackets again, but within the brackets I'm going to do the division first. So 81 divided by 9 is 9. And then within the bracket still, add on the 3, gets us a total of 12, and then multiply that 12 by the remaining 3, gets us 36. Next up, 5 6 of 420. Just to make this easy, I'm going to make that 5 6 of 420, and then I'm going to add the 0 back on at the end. So let's start with 42, divided by 6, gets us 7, and 7 multiplied by 5 is 35, put the 0 back on, as a total of £350. Next up, find the product. So we'll say 10 times 12 is 120, and then we'll say 8 times 12 is 96. 96. Add the 2 together, that is 6, 2, add the 9 is 11, so 1 carry the 1, 216. And then 36 times by 0.5. Remember, if you're multiplying 0.5, it's the same as a half. So really what we're saying is, what is half of 36? Answer is 18. Next up, some percentages. So first off, we want 15% of 65. 10% of 65 is 6.5. Remember, to find 10%, you divide by 10. Then we need to find 5%. Well, that's half of 6.5. So that's going to be 3.25. Add the 2 together, that is 9.75. Remember, you work in monetary terms, so that's £9.75. Next up, we want 30% of 132. So again, start off with 10%, and that's going to be £13.20. We want 30%, so 3 lots of that, and that's going to be £39.60. And then the number machine. So start with the 15 and then follow the process. So 15 times 4 is 60. Take away 3 is 57. And then start with the 97, we'll do the opposite every time. So that's going to be, so the take away 3 is going to become a plus 3, times 4 is going to be a divide by 4. So 97, add the 3 is 100, divide by 4 is 25. Next up, right, 242 is a product of prime factors. Okay, so start with 242, even numbers, so I can split it by 2, and half of that, which is going to be 121. 121 is a square number. I know it's 11 squared. Now, 2's a prime, 11's a prime, and the other 11's a prime. So written out in index notation, that is 2 times 11 squared. And there it is, product of prime factors. Next up, about hundreds and thousands. This week we'll concentrate on the thousands. So 24.5 times 1,000 will be 24,500. Put a comma there after the 4. And then 640 divided by 1,000. So remember, if you divide them by 1,000, decimal point moves forward 3 spaces. So it starts here behind the 0, moves in front of the 6, to end up with 0.640. Next up, list the factors of 49. So I think 1 in the number itself will always be a factor. So you got 1 and you got 49. 2 doesn't go in because 49 is not an even number. 3 doesn't go, 4 doesn't go, 5 doesn't go, 6 doesn't go. First number is going to be 7, 7 sevens. So your factors there, you've got 1 and 49 and you've got 7. Next up, we're going to do some fraction arithmetic. So to add, remember the method, you multiply the bottom 2 numbers together. So 3 times 4 gets us 12, and then 4 times the 1 is 4, 3 times the 3 is 9, and we're adding those 2 things together. 4 add 9 is 13. We're working in twelfths, so we've got 13 over 12. Could simplify that one step further by taking the whole one out. Remember, 12 twelfths will be 1 whole, and then you've got 1 left over out of 12. And then for the subtraction, same method, only we're taking away the top 2 numbers. multiply the bottom two. 8 times 3 is 24. 3 times 7 is 21. 8 times 2 is 16. And this time it's a takeaway. So 21 take away 16 is 5. Working something over 24. Can't simplify it in any way because I know 5 is a prime number. So there's my numbers. Next up, same process for algebra. So when the screen appears, press pause. And then when you press play, I'll talk through the answers. Okay, so pause now. Okay, so let's have a look. The first one's all about simplifying, so we're collecting like terms. So remember, I can collect all the x squares together. So effectively, I've got 1x squared, take away 5x squared, leaves me with minus 4x squared. So I've dealt with that term, and I've got a plus x. Remember, x isn't the same as a term in x squared, so we just have to leave that separate, plus x. Next up, if I have 5y squared and I take 5y squared away, I have 0y squared. So effectively, that term is cancelled out. I don't have to write it, but I do have a y cubed. So y to the power 3 or y cubed. Next up, solve for x. Remember what that is. That whatever x is, I'm going to multiply it by 3. I'm going to add on 4, and the answer's got to equal 31. So I'm treating this as kind of like a number machine working backwards. Starting with a 31, I'm going to do the opposite. I'm going to take away the 4, leaves me with 27. 27, do the opposite, divide by the 3 gets me 9, so I know that x must equal 9. For the next one, you've got minus 5, you're going to add something to it, in this case x, and that's going to get me 20. Well, I've got the positive 20, and I've got the 5 that I'm going to need to add to that, so x is going to have to be 25. You could, of course, rewrite that as x is equal to 20 plus the 5, which also gets you 25. Next up, simplify. So we're multiplying things together. Now remember, d on its own is really d to the power 1. If we remember back to our laws of index, when you're multiplying things with powers, you're really adding the powers together. So d1 times d3 times d squared, you can simplify to d. 1 add 3 add 2 is 6. So that's d6, or d to the power 6. Multiply the numbers together. 2 times 2 is 4. That's 4d to the power 6. Next up, 5 times d squared times 18. We'll think 5 times 18 is going to be 90, and then I've got 90d squared. Solve for x. So we've got x minus 1 is equal to the root of 49. Well, the root of 49, I can simplify, is really just a 7. So x take away 1 is 7, or working backwards, 7 add the 1 is 8, so x must equal 8. For the next one, we've got x squared plus 1 is 145. Now, if I take 1 off both sides, what I'm left with is x squared is equal to 144. 144 is also a square number, it's 12 times 12. So x must equal 12. All I've done there is square root of both sides, get 12. Next up, simplify. 1ab and 3ab is a total of 4ab. Take away 2c, take away 2c, list that separate. Next up, I can combine the b terms, so 2b and 7b is 9b. So we've got 9b, and then we've got the 5ab as a separate term, so 5ab. Now I've listed those alphabetically. I've gone with the ab before the 9b. If you've written 9b plus 5ab, it's still correct. By convention, you usually list your highest powers followed by your terms alphabetically. Next up, solve for z. 48 divided by something equals 16. So think, how many times does 16 go into 48 as a whole number? So count them in 16. So you've got 16, 32, 48. It goes in 3 times. So z must equal 3. Similar kind of thing for the next one. 45 divided by something is 9, or 9 times something is 45. It's 5. So z equals 5. Some more two-step equations. So we've got 9x minus 4 equals 59. So again, remember that's whatever x is. I'm going to multiply that by 9, take away 4, and my answer must be 59. So if I treat it again as a number machine and work backwards, start with a 59, do the opposite. Add on the 4 gets me 63. 63 divided by 9 is 7. So that one, x must equal 7. For the next one, it looks a little bit different. We've got 6 plus 2x equals 14. So again, if I write that out in terms of bid mass, that is whatever x is, multiplying it by 2, then I'm adding on the 6, and that's got to equal 14. So working backwards, starting with a 14, I'm going to do the opposite. I'm going to take away the 6, leaves me with 8. 8 divided by 2 equals 4, so x must equal 4. And then expand the brackets. A bit shorter room to do this one, but the right answer should be multiply y by y, gets you y squared. And then you do y times 2, which is plus 2y. then do the inner 2, so 2 times y is plus another 2y, and then the last one in each bracket, so 2 times 2 is 4. So remember the acronym, it's FOIL. That's first, outer, inner, and last. And then we can simplify the final expression there. So we've got y squared, 2y plus 2y is a total of 4y, and then plus 4 at the end. For the next one, same process, just slightly more complicated terms. So we say 4y times 2y is a total of 8y squared. Then we do the last termini, the outer termini. So 4y times minus 2 is minus 8y. Then the inner two terms, so plus 4 times 2y is plus 8y. Then 4 times minus 2 is minus 8. Now when we simplify this, note that we've got a minus 8y and a plus 8y, and those two terms will cancel out. So that's going to be, for our final answer, 8y squared. The two terms of y are cancelled, so we've just got 8y squared minus 8. And then for the last one, we've got x squared plus 4x plus 4, and we need to factorize that. So we're looking for two numbers that will multiply together to get 4. So think your factor pairs, you've got 1 and 4, and you've got 2 and 2. And we're looking for the pair. We'll add or subtract in some way to give me this 4. Well, 2 add 2 is 4, so that's our right answer. So plus 2 here, plus 2 there. And that's the correct factorization. Right, folks, that was the algebra stuff. Hopefully we've done all right. Onwards to the lesson. Right, folks, so first up we're going to multiply some decimals. Okay, so the first couple, probably fairly straightforward. I'm sure you'll be able to manage these, but there is a good method to try to work out some of the more complicated ones. So I'll start off simple and work to the tricky ones. First off, we've got 3 times 0.5. Okay, so the method I'm going to try and apply to all of these is going to be step 1, I'm going to count all the digits after the decimal point. In this case, we've got 1 digit after a decimal point. Step 2, I'm going to multiply the whole numbers. And then step 3, I'm going to put the decimal back in place. Okay, so 3 times 5, so 3 times 0.5, there's 1 digit after the decimal place. Multiply the whole numbers, so 3 times 5 is 15, and then put the decimal place back. So I need a total of 1 digit in my answer after the decimal place. So 15 becomes 1.5. Now this method will work for anything, regardless of how complicated the numbers are, as we should see. Right, so here's the next one. We've got 0.4 times 0.5. Remember the method. We're going to count the digits after the decimal point. Then we're going to multiply the whole numbers together, and then we're going to put the decimal place back in. So first off, I've got the 4 and the 5, so that's 2 digits in total after the decimal point, so 2 digits. I'm going to multiply the whole numbers together, so that's 4 times 5 is 20, and then I'm going to put the decimal place back in, so my answer needs 2 digits, so 0.20, which you can of course simplify to just 0.2. You can miss off the trailing 0. Okay, so the next one, we've got 0.12 times 0.5. Method remains the same. We're going to count the digits after the decimal point. We're going to multiply out the whole numbers, and then we're going to put the decimal place back in. Now this time we've got the 1 and 2 from 0.12, so 2 decimal places there. We've got the 5 from the 0.5, a total of 3 digits. So our answer is going to need 3 decimal places. Then we're going to multiply the 12 and the 5 together to get 60. We're going to put the decimal back in place. So that's 060, because remember our answer needed 3 decimal places. And remember, you can omit the trailing 0 to 0.06. Right, folks, next up we've got 0.7 times 0.9. So what I'll do is we will count up the digits. So we got 1 there, 1 there, so that's a total of 2 digits. So my answer needs to have 2 decimal places. Multiply the 7 and the 9 together. 7 times 9 is 63. So I need 0.63. Just make it clear that that's a 6. So my answer needed 2 decimals is the answer. Next up, slightly more complicated, we've got 0.11 times 0.8. So again, remove the digits. So I've got 2 there, 1 there, so that's a total of 3 digits. Let's write that in, 3 digits. So my answer must also have 3 digits. then multiply the whole numbers together, so 11 times 8 is 88, and then write that as a 3-digit answer, so 0.088. So that was the first digit, second digit, third digit. Next up, we've got 0.04 times 0.7. So again, we've got 2 digits there, 1 digit there. So again, my answer is going to have to be 3 digits. We're going to do 4 times 7, which is 28. So I need 0.028. So that's 1, 2, 3 digits after the decimal point. Hopefully we're starting to get the hang of this. Let's try one last one and then maybe try a few practice questions. So this time I've got 2 digits there, 1 digit there. So that's 3 digits in total. So my answer needs to be 3 digits after the decimal place. We'll do the multiplication. So 3 times 7 is 21. So my answer is 0.021. I need 1, 2, 3 digits after the decimal point. Right, folks, a couple of questions there for you to have a go of. Pause the video, and then when you press play, I'll put some answers up. Okay, so the answers we should have had for those. The first one should have been 0.24, and 0.36, and 0.40. But again, remember that's still right if you choose 0.4 because you can remove the trailing 0. And then the last one is 0.108. So well done if you got those. Okay, folks, now, depending on how strong you are with multiplication, you might find these fairly straightforward or you might find them quite challenging. What I would recommend is pause the video, attempt the questions. These will probably take you some more time. Don't feel like you've got to do all of them now. Maybe do the first column and then save the next column for a later time just to get some repetition in there. And then when you press play, I'll put some answers up, see how you did. Right, folks, there's the answers. As you can see, some of these are quite challenging questions, but very well done if you got any of them right. Right, folks, so that was the end of the multiplying decimals part. The next part of the lesson, we're going to be talking about how to work out the area of the circle. Before we do that, we need a little bit of a recap on how to round numbers. So we've got some numbers here. We should all be able to do this already, but pause the video, attempt these questions, and then I'll talk us through some answers with a bit of explanation just to make sure we got them right. Okay, so we're rounding all of these to 1 decimal place, so my answer needs to have 1 decimal point. So the first one, the 3 is the important number. That's the last number that I need to include. Now the 3 can stay the same or it can round up depending on the digit before it. So if the digit that precedes it is a 5 or higher, it's going to round up. In this case, the digit before it is a 6, so it does round up, so that's going to be 37.4. For the next one, 0.851, again, we're looking at the 8, it might stay the same, it might round up, depends on the digit of the value of the digit before it, in this case a 5. So that one again will round up. So to 1 decimal place, that one is 0.9. And the next one, we've got 4.04. 0 is the important one. That might change depending on the value of the digit before it, but in this case it's a 4, so it doesn't change. So that one to 1 decimal place is 4.0. And then we're looking at 4.626. So again, it's the 6 that's important. That's the last digit in our answer. It might stay the same, it might change. The digit before it is a 2, so it doesn't change. So that one ends up being 4.6. The next one, the 3 is rounded up because of the 8, so that is 78.4. And then for the last one, 0.05, it's the 0 that might change. The digit before it is a 5, so that will change to 0.1. So all of those answers are rounded to 1 decimal place. Right, folks, I'll explain why that was going to be relevant in a sec. Next up, we need to do a quick recap on the parts of a circle. So here's my circle. First up, we have the radius, which is a straight line extending from the center to the circumference. The circumference is the line that denotes the distance around the edge of the circle. The tangent is a line that touches the circumference at only 1 point. So imagine that line, if you zoom right in, only barely touches the very edge of the circumference. The diameter is any straight line that passes directly through the center of the circle and is the longest distance from one side of the circumference to the other. And then you also have a chord, which is any line that does not pass through the center. Now, the important ones for us today are going to be the radius and the diameter. Important to note that the radius is from the center to the outside, and the diameter is all the way across, so from the outside to the center to the outside in one straight line. So if you have the diameter, it is equal to 2 times the radius. If you have the radius, it is equal to half of the diameter. Important to remember. So if you've got a diameter, you can half it to get the radius. If you have the radius, you can double it to get the diameter. Important to remember. Right, folks, so area of a circle. We need to know this particular character. This is the Greek letter for p. It's called pi. Very important in maths. It has an approximate value of 3.14. So if you're working at home and you don't have a scientific calculator or an easy way to use pi, then you can use the value 3.14 and that'll be fine. Educast, the exam board that we use, want us to use the value of 3.14 unless the question states otherwise. Okay, so here's the area of a circle formula. So the area is equal pi r squared. Now remember what that means. That is pi times whatever the radius is squared. Okay, so example 1 for area of the circle. We've got a circle, it's got a radius of 5 centimeters. We refer back to our formula. We know the area is pi times the radius squared. So we'll replace the r for the for the number 5. So we've now got pi times 5 squared. Now if I didn't have a calculator, I know that 5 squared is 25. So I can write that as area equals pi times 25. Which means that the area is 25 pi centimeter squared. Now, if you were doing this on a non-calculator paper, you can leave your answer as that, and that is called in terms of pi. So if a question says leave your answer in terms of pi, that's what it's looking for. If you're doing a calculator paper and you had a calculator, you can then just do pi times 25, and that gets you 78.539, whatever it is, centimeter squared. Now, if you're using 3.14 exactly, your answer might be slightly different than mine. I'm using a scientific calculator to work mine out, and it's using a very accurate version of pi. Okay, example 2. This time our radius is 3 millimeters. So we start off with our formula, area equals pi times r squared. We replace the r with 3, so pi times 3 squared. I know 3 squared is 9. So really, that's going to be, if we were not using a calculator, that's going to be areas 9 pi millimeter squared. Or if we're using the scientific calculator, we will use the calculator to work that out. That's 28.274, whatever it is, millimeter squared. Now, in this case, the question's asked us for our answer to be accurate to 1 decimal place. So we're looking at the 28.27, and that's rounded to 28.3. Reason for that is the 2 here is the last digit in my answer, but it could change depending on the value of this digit here. And because it's higher than a 5, it'll round that 2 to a 3. So the answer is 28.3 millimeter squared. Remember, any answer where it's asking for the area, your unit is going to be whatever unit you're working in squared. Okay, so example 3. So remember, area equals pi times radius squared. I'm going to do this without a calculator. So we've got pi times 6 squared. Now I know 6 squared is 36, so that's pi times 36, which is the same as saying 36 pi. And all my unit was meters, so that's meter squared. So I could happily leave my answer like that, and that would be correct. However, the question says it wants our answer to 1 decimal place. So let's use a calculator. That's 36 times pi. Now, my answer, as shown on the calculator, is 113.097 something something something, and that was in meter squared. Now remember, the question says 1 decimal place, so I want the 111 point. Now this 0 here might change depending on the value of the digit before it. The digit before it is in 9, so that will round up, so that's 111.1. We're working in meter squared, and that was accurate to 1 decimal place. Next up, example 4. Now this time it's a little bit different because our circle doesn't give us the radius, it gives us the diameter. So if we know the diameter is 8, the radius is half that, so the radius is 4. So using that, we've got the area is pi times the radius squared. So that's pi times 4 squared. I know 4 squared is 16, so that's pi times 16. So in terms of pi, that is 16 pi centimeter squared. But again, question here is asking us for the answer to 1 decimal place. So in terms of putting that through a calculator, the answer should be 50.265 ... and we're working in centimeters, so answer is centimeter squared, and then round that, so the answer is 50.3 because the 2 rounds up because of the 6 before it. Don't forget your unit, you're working in centimeters squared. Last one, again this time we've got the diameter, so if the diameter equals 20, then the radius must equal 10 because it's just half. So what we'll do is, here's our formula, area equals pi times the radius squared. So that means pi times 10 squared. I know that 10 squared is 100, so that's pi times 100, which is the same as saying 100 pi, and we're working in meters squared. And again, it says to 1 decimal place, so let's get our scientific calculator. So 100 times pi gets me 314.159 something. Still working in meters squared. And again, to 1 decimal place, that is 3.14.2. So if we look at the answer above, the 1 here is going to round upwards because of that 5. So we want 314.2 meters squared. And that's our area of a circle. Right folks, so a couple of exercises for us to try there on the board. What I would like to do is pause the video, attempt the questions, and then see how we get on. I'll put some answers up in a second. Right folks, so there's our answers. Now just remember, depending on the value of pi, so if you're using the exact value of pi, you should have the exact same answers that I've got. If you're using 3.14, your answers may be very slightly different, but should be very close to what we've got there. Right folks, very last thing, if you want some extra practice, feel free to have a go at some of these. So all the ones on the left hand side you're given a radius, all the ones on the right hand side you're given the diameter. So again, pause the video, attempt the questions, when you press play, I'll put some answers up on the board, make sure you got them right. Okay, so there's our answers, and again what I would just say is that if your answers look pretty close to that, they are likely going to be correct. Just remember that if you're using 3.14 rather than the exact value of pi, your answers may in some cases be very slightly different. And that's area of a circle. So hopefully we were all right with this in terms of the topic. Please do remember to try to catch the live versions of the sessions every week, and do make contact with your tutor if you're getting stuck or struggling with any aspect of the course. Still got the revision grids to go. So on the next slide, you'll see a load of questions related to geometry measure. When they appear, press pause and then attempt the questions. The following slide after that would be data and stats related questions. Again, same process. When the questions appear, press pause, attempt them, and then when you press play, I will talk through some answers. Here's the geometry measure question. So press pause now. When you press play, I'll talk you through the answers. Okay, so for the first question, we're calculating the area. This is effectively compound area, so we're going to try to make 2 shapes. So if I cut it this way, and there's other ways to cut it, then this rectangle here is 3 by 4 centimeters, so that's a total of 12 centimeters squared. The next one, I know it's 10 centimeters high, but I need to know this width here. Now I know the entire shape is 9 centimeters wide, and we've already accounted for the first 4 centimeters that way, so this bit here must be 5 centimeters. Which makes this rectangle here 50 centimeters squared in total. So the total area would be 12 add 50 is 62 centimeters squared. Next up, sketch a cuboid. So cuboid should look in 3 dimensions a little bit like this. Next up, sketch a cylinder. Again, apologies for the bad drawing, but a cylinder should look a little bit like one of these. And next up, reflect the shape. So now you might just be able to do this, but I tend to do a point at a time. So from when I've denoted the point there, it's 1 square to the mirror line. So reflect 1 square out. This point here, 2 squares to the mirror line, reflects 2 points out, or 2 squares out. The bottom one, same again, 2 squares to the mirror line, 2 squares out. And then this point is 3 squares to the mirror line, so 3 squares out. That point is 2 squares to the mirror line, 2 squares out. And that point, 3 to the mirror line, so 3 out. And once you've got your points, just draw in your shape. Next up, name of that shape. Well, count the amount of sides. You've got 1, 2, 3, 4, 5, 6, 7, 8. So that is an octagon. 8 sides is octagon. So one of the important ones, you've got 5 sides, which is pentagon, 6 sides is hexagon, 7 sides is heptagon, octagon, and you've got 9 sides, which is nonagon, and then 10 sides is decagon, and you might get a 12-sided shape come up, that's a dodecagon. Next up, how many lines of symmetry does the shape have? Now, difficult to draw, but remember you have a line of symmetry going through here. So that's 1 point and then the opposite flat side. So effectively, you've got 1 line of symmetry for every point around that shape. So that's a total of 7 sides, 7 lines of symmetry. And just remember, for any regular shape, if you have a regular shape with, say, 9 sides, it would have 9 lines of symmetry. If it has 22 sides, then you would have 22 lines of symmetry. But it only works for a regular shape. Remember, a regular shape is one where all the sides and all the internal angles are the same. Next up, sketch the net of a trapezoidal prism. So first off, start with trapezium. And remember that a prism is just any object that has the same cross-section all the way through. So if we extend that into 3 dimensions, that would be a rough sketch of a trapezoidal prism. Next up, it says enlarge the shape by a factor of 1/2. And remember, enlargement often gives the impression that it only applies to shapes where they're going to get bigger. But if you enlarge by 1, then the shape stays the same size. If you enlarge by a factor of 1/2, it actually halves the size. So looking at the width of the shape, it's currently 4 squares, and it's currently 4 squares high. So the enlarged shape is going to be 2 squares high and 2 squares across. This shorter vertical side here is currently 2 squares. The enlargement needs to be half that and 1 square high. And once you've got that, it's easy to just fill in the rest of the shape. So that is the enlarged shape. Just make that a little bit thicker so we can see where it is. And then lastly, calculate the area of a trapezium. Just remember, there's a couple of different ways to remember this. Some people remember the formula, and the formula is 1/2 a plus b times h. But I've pretty much stuck to teaching the 3-step rule. So add the 2 opposite sides together. So 5 add 12 is 17. Step 2, multiplied by the height. So 17 times 4 is 68. And then half it. So 68 divided by 2 is 34. We're working in centimetres, so for an area, it's 34 centimetres squared. Well done if you got those right. Lastly, we've got the data and stats. So pause now, attempt to answer the questions, and then I'll talk through some answers in a minute. Okay, so looking at this one, it says provide 1 comment on the graph and what it shows. It shows GCSE pass rates over time. So GCSE pass rates over time. Okay, just a quick note on this. If we look at these, it says annual GCSE maths pass rate in England and Wales. This information in particular was solely relating to the FE college provision. Should point out that in the last time that we sat exams was 2019, and we were actually up here somewhere. We were 49%. So we are very good. That means you guys are very good. But nationally, the college sector does very poorly for GCSE maths. Next question, looking over here, it says describe the trend. Well, if we look at the trend, it's going down year on year. So describe the trend, results are decreasing. Or words to that effect. Results are decreasing. Again, apologies for the slightly scrabbly handwriting. I'm doing the best with the tools that I've got. Next up, what is the difference between 2015 and 2018 result? Okay, so 2018 was 23.7, 2015 was 35.8, so let's do the math. That's 35.8, take away 23.7. 8 take away 7 is 1, decimal point. 5 take away 3 is 2, 3 take away 2 is 1, so that's 12.1. Now remember, these are all as percentages, so that's 12.1%. Always try to include your unit of measure. Next up, give a valid criticism of the graph. Well, it's got everything it needs. It's got a title, it's got its axes clearly marked, the bars of equal width, the gaps between the bars are equally measured. It looks like a pretty good graph, but it's not considering the context. I had to explain this, and you might have got it if you knew what this bit meant. These are all FE related results. You might have at first glance mistook that for all schools when it's not, so it doesn't explain the context. And then lastly, it says, give an estimate of what you would expect the 2019 pass rate to be. Now, as I say, nationally, that figure continued to drop. So you would think of it as if you sort of see a bit of a trend going in that sort of direction, you might think by 2019 it should be around about there. So read that off the scale. It's probably just under 20%, so we call that 19% or thereabouts. Again, that's open to interpretation. It is your estimate, but as long as you are somewhere in the ballpark, so I would say anywhere between say 22 and about 18, you're probably not far wrong. And that's the data and stats for this week. Right, folks, so that was multiplying decimals and area of a circle for this week. Hopefully it's been of some use. Again, if you're stuck or you're struggling with any aspect of the course, please do get in touch with your course tutor. Thanks.